Welcome to the Tomorrow's World Today podcast. We sit down with experts, world-changing innovators, creators, and makers to explore how they're taking action to make tomorrow's world a better place for technology, science, innovation, sustainability, the arts, and more. And now, this week's episode.
In this episode of the Tomorrow's World Today podcast, George Davison, who is also the host of Tomorrow's World Today on Science, interviews Jackie Birdsall, who is the Senior Engineering Manager at Toyota North America. Jackie delves into Toyota's pioneering advancements in fuel cell technology, exploring their evolution over the past 30 years and the recent innovations that are shaping the future of sustainable energy. She gives us an in-depth look at Toyota's dynamic approach to brainstorming and problem-solving, highlighting the balance between individual inspiration and collaborative team efforts that drive their R&D. Now here's George.
Well, today we have Jackie Birdsall, and she is with the Toyota Corporation. I think it might be better that I let you say your title for what you're doing at Toyota.
Yeah, sure. Thank you so much for having me. I am a Senior Engineering Manager in the Fuel Cell Development Department at Toyota under the Research and Development side of the house.
Wow. So you get to explore the things before they become common to everybody else, right?
That's right. Our group pretty much builds the first of kinds. We build the prototypes and make sure that they are ready for commercialization before handing them over to our production team.
Nice. So do you have any pet projects that you're working on right now that you'd share with our audience?
Well, unfortunately, as part of research and development, most of what we work on is confidential. So, no, I cannot talk about any of my current pet projects.
All right. Can we chat a little, though, about, let's say, a project that's recently become public aware?
Absolutely.
More to the public domain?
Absolutely. Yeah, so our team was the team that first brought the first generation Toyota Mirai, which is our hydrogen fuel cell electric vehicle. We brought the first generation and the second generation to North America. And from that, we started to kind of look around and think about ways that we could use that same technology, the fuel cell technology, to decarbonize other aspects outside of just the light duty market. And so our team actually, we're located about 15 minutes from the Port of LA, Port of Los Angeles, and Port of Long Beach, which is the largest port in the United States. 16,000 diesel semi-trucks come in and out of that port every day, right? The impacts of the air quality around the port is really horrendous to human health as well as to the environment. And we thought, well, what happens if we take that same fuel cell out of the light-duty vehicles and we put it into a Class 8 semi to demonstrate that we can pull 80,000 tons with zero emissions? We kind of brought this up to the higher ups, and they were like, we don't build trucks in the U.S. You never see a Toyota semi driving down the road, right?
Right.
So we bought this Kenworth chassis without anyone knowing about it, gutted it, took apart 2 light-duty fuel cell Mirais, put those fuel cells into the truck, and demonstrated to the world for the first time that we could power a heavy-duty truck with the same fuel cell technology we use in our light-duty vehicles. Since then, we've built 12 more of these trucks. We've put, hundreds of thousands of miles on these trucks to demonstrate durability, and we're going into production next year with PACCAR to build them here in the United States to decarbonize the transportation industry as we know it. And we didn't stop there. Then we thought, okay, well, what about the rest of the port equipment, right? There's all these pieces of equipment around the port that are all operating on diesel. All of those we can repower with hydrogen fuel cell technology and turn the port into a fully zero emission operation, which is really ultimately our goal, right? So we've built utility tractor rigs, top pick handlers, rubber tire gantries. These are all just words for the equipment that moves the containers around the port. We've built first of kind for all those that are also powered by our hydrogen and fuel cell technology. So we're branching out beyond our traditional light duty space now and putting fuel cells into everything that we can think of.
Well, it sounds like a great initiative. I'm sure you enjoy being a part of something like that. We always look for things that have a noble cause attached to them, and that sounds like it's got a great noble cause.
Yeah, I think I'm very lucky to work with the team that I do because everyone is so purpose-driven, and it's not just our team, right? It's throughout the core of the company. Environmentalism is really part of one of our key initiatives, and all the way from the top, they're saying, how can we decarbonize as quickly as possible? As you know, it's a huge issue right now that we're facing, and it takes every tool in our toolbox to figure out how to decarbonize as quickly as possible.
Thanks for sharing that story with me. So, you've mentioned fuel cell And so can we chat a little bit about that technology? What is fuel cell technology, and how is it going to change our future?
Yes, it's an excellent question. I think a lot of people are not familiar with fuel cell technology, so thank you for asking that. Essentially, it's an electrochemical device, which just means there's no combustion, right? It's all electrons. And we introduce hydrogen on one side and oxygen on the other. And if you're, ever see hydrogen out in the atmosphere, it's never by itself, right? It always wants to be bonded to something. Like think of water, H2O, right? Mm-hmm. So that hydrogen sees the oxygen, it wants to bond. And we give it the right conditions in the fuel cell, the right temperature, the right humidity, and it hits a platinum catalyst, and that excites the electron and the proton. And we have this membrane between the two sides, between the two plates of the fuel cell, that only allows the proton to travel through, which means the electron is still stuck on one side of the fuel cell. It cannot pass through that membrane, so it needs to find a conductive path around that membrane. Okay. And you get that reaction happening fast enough, you get a flow of electrons, there's your electricity. And that we then use to power an electric motor. So the fuel cell vehicle itself is just like a battery electric vehicle, but instead of plugging it in and recharging it, you refill it with hydrogen, and then the hydrogen and oxygen combine to create water in the fuel cell, and a byproduct of that is the electricity that powers the vehicle.
Very interesting. So in a traditional engine, we are introducing a fuel that is creating a combustion.
That's right.
And that's consumed, and then you expel that through the pipe at the back of your car. And that is where we get our pollution, right? So in this situation with a fuel cell, a car run by a fuel cell, we are introducing what? Can you go through that again? And expelling what? So we can see that piece of it. And then are there moving parts, or have you eliminated a lot of the moving parts of an engine? Because you have to make all those parts of an engine as well, which does cause issues.
Yeah, so what you were introducing is gaseous hydrogen. So most of the Mirais are in California, as far as U.S. Pull up to a traditional hydrogen station. It's normally co-located with a gasoline retail station. So pull up to a station, connect the nozzle. That's all gaseous hydrogen. Then you drive off, and then what's happening in the vehicle is the hydrogen is combining with the oxygen just from the air, from the intake system. Okay. And that creates the electricity that then goes to the electric motor and propels the vehicle. And so to your point, there's no pistons, there's no spark plugs, there's no combustion. What there is there's an air compressor to introduce the oxygen. There's a hydrogen pump to introduce the hydrogen.
Yes.
But it's not mechanically driven the way that a traditional vehicle is.
Okay. Can you walk me back a step? How do I get gaseous hydrogen into my station where I pump that in?
Excellent question. We've actually been safely manufacturing and moving hydrogen in the U.S. since the 50s. We use it for the NASA program. It's used in everyday products that you may not think of, like toothpaste. Any place that you have an oil refinery traditionally will have a hydrogen plant, because they use the hydrogen to actually reform crude oil into gasoline. So we make a lot of hydrogen right now. Most of that is made from a process called steam methane reformation, which is you put high temperature water, steam, through methane, and you break off the hydrogen. Problem with that being there is still that carbon associated with methane, right? Methane CH4.
Yes.
So we want to move to 100% renewable hydrogen. And the way to do that is through biogas and through what's called electrolytic hydrogen, where you can use wind and solar to create hydrogen from water. So when you ask, where do we get the hydrogen? Totally depends on the station. Most stations in California get their hydrogen from biogas-derived hydrogen. Okay. So you use whatever your waste gas may be. One of the beautiful parts about hydrogen is it's very abundant. You can use whatever your local renewable source of hydrogen may be. In the case of California, we're a big agricultural state. We have a lot of biogas. We have a lot of agricultural waste. Right. So we can take that, we can create hydrogen from that. It then gets delivered to the station either in gaseous or liquid form, depending on how much hydrogen you use. And it's very similar to a traditional gasoline station, where you just go in and you refill the tank as often as is needed. That's the idea behind the hydrogen stations as well.
Sounds great. And I want to thank you for that explanation, because I think it'll help people understand a lot more. And if you could walk us back a little bit and talk a little bit about what kind of an engineer you are, I think that would be good for everybody to know.
Sure. Mechanical engineer. I went to school, I was born and raised in California, but went to school in Michigan because I was enamored with the automotive industry. I really wanted to get into the automotive world. And I actually was most interested at the time in supercars.
Okay.
So talk about probably the least environmentally friendly vehicles out there. But the engineering behind them was just fascinating to me. And it just so happened that one of my first classes in university was on hybrid electric vehicles. And the professor started the class with a lecture on, at the time it was petroleum dependency. It wasn't even climate change, right? We didn't even know that, it was just starting to be discussed, but we really didn't know about climate change at the time because I am an older engineer. But he talked about petroleum dependency, he talked about the negative impacts of petroleum on the environment, and then obviously on pollutants, on the exhaust of vehicles, on human health and the environment. And it completely changed the trajectory of my career. I immediately, I recognized that the industry I was in love with had this big negative consequence, and I wanted to figure out a way to make it not, to solve that, to still build these incredible cars and give people personal mobility, but do it without all of those negative impacts.
So when you were younger, did you have a mentor, or how did you, as a young person, let's say maybe middle school, discover that the world of engineering was interesting to you?
That's a great question. I actually didn't know engineering existed until I was 16 or 17. But what I did know in middle school was I was on the science Olympiad team in school. I knew I loved science. I didn't yet know that I loved math, but I definitely recognized that, Science Olympiad's an opportunity to do kind of your own experiments, and we did like the egg drop thing where you have to protect the egg when you drop it from the roof, and I really enjoyed those kind of activities. So yeah, I think early on I knew I was into science. As far as mentor, no, I don't think I had a real mentor. I really admired Bill Nye the Science Guy.
Sure, yeah.
As most people my age did. But yeah, no, I was not aware of engineering until I was older, unfortunately. I wish I knew younger that it was an opportunity for me.
Well, science is a broad subject.
It is.
So looking at science and being curious and then navigating your way into engineering one day, I think that sounds a little like normal.
Yeah.
Right?
Yeah.
Because problem solvers, people who like to make things better, I see that quite a bit. So, all right. Well, how about when you were in school? It sounds like you liked science. Did you have a teacher that inspired you when you were in school?
Yes. It's funny because I've actually tried to find this teacher since, because I don't think he recognized the impact that he had on my life. I think a lot of teachers, don't recognize the impact they have on people's lives, but they can have these one moment that just kind of flips everything for you. For me, it was in high school. I was not doing very well in math. I was trying to figure out who I was. It's a big change time for students. It wasn't really cool to be nerdy, and so I struggled with that. I was just struggling where I fell in like the social norms and everything. All I know is that I was doing poorly enough in math that I wasn't allowed to start for my soccer team, and soccer was very important to me. And this teacher, bless him, would stay after school to tutor me to get my grades back up. In his pre-calculus class. And we had this, back to school night, and my dad came in and he was talking to him, and I just overheard him say, "Your daughter understands this better than any other student I've ever seen. She should go to MIT. Like, she knows math." And it gave me so much confidence, and it completely changed my relationship with math. I mean, I went to get, I was in the National Honor Society for mathematics, doing very advanced mathematics in university. And it was all because this one teacher kind of gave me confidence in my skills and my capabilities with math, but then also just made me feel, proud of it.
Yes.
It really inspired me. So
I'm good at something.
Yes, that I have, that I had something to offer, and it was really cool. Yeah, so I do have one teacher in particular that really changed the course of my life.
Well, thanks for sharing that story with us.
Yeah.
Because I'm sure you're not the only person out there that struggled with that social environment, with academics, with sports. I mean, that's like an amalgamation of who knows what for all of us when we're at that age, right?
Yes, and you're trying to figure out, in the meantime, also the course of your rest of your life, right? Like, where do you go to college? What are you going to study? Who are you going to be? Along with all of that stuff in high school, it's a lot to ask for a young adult or a kid.
It really is. So, but we get there somehow or
We
another.
do. We sure do.
All right, so let's chat about brainstorming for a minute. It's great that you're in the R&D side, because I think this world of brainstorming is so important for engineering and solving problems. Can you talk a little bit about what that's like where you're working at Toyota now? And is that a individual activity? Is it a team activity?
It is both. It is both an individual activity and very much a team activity. I guess two examples that are off the top of my head. One was I was working with this lab up in British Columbia on stuff that we were doing for Toyota R&D. And as I was flying back, on the plane is actually where I do some of my best brainstorming. I think it's because I unplug from everything and I could just really sit there with my thoughts. And by the time I landed, I had put together this entire presentation saying, how we could do this job more efficiently. And I came back, I had to pitch it to my boss, and part of that was to send me to Japan for 13 months to train on this particular, it was on the hydrogen tanks for the Toyota Mirai. Send me to Japan for 13 months, train me up on this, let me build a team in Los Angeles to do this job, and we did it. Wow. And I got the green light, and I moved to Japan, and I was there for 13 months, and I trained on it, and it was all from this one idea that popped into my head while I was on the plane, So I think that's an example of an individual brainstorming session. But then one thing that we do at Toyota every year, we have this customer first confirmation day. And all that is each team shuts down all work and we all sit together for an entire day just to brainstorm. And typically we'll choose, one topic that we're really struggling with. But it's very rare to get all of the teams together in one space. We call it whiteboarding. We love whiteboards and markers. It's so many ideas come out of whiteboards and markers. And we just sit around together as a team. And every year we do this, and every year we solve some big problem because we have all of the backgrounds from all of the different engineers and all their experiences sitting there and looking at a problem together. And someone will always have a different idea than you do, right?
Yes.
And it's really what drives so much of the innovation of the company is having all these individual thoughts and backgrounds and experiences all providing all these possible solutions to a problem.
Yeah, and looking at it from their lens, hearing what they're saying, and then looking at it, let me think of it that way for a minute. Oh, you could see a lot more. Maybe a different light goes on, right?
Exactly.
Yeah, when we're doing our brainstorming, I try to get our people trained on sketching because it's an art of communication. So we can verbalize, but if I want to really get my idea across to you, if I can also sketch it, I can help tell more of that story to you.
Yes.
And then we like to do that at a round table that's smaller, so that the idea is I want you to cheat off what you're seeing me sketch. And then I'm looking at what you're sketching, and we get this lift at the tail, like, what? Oh my, and then we get this fire going in our minds. Anyway, that's part of our brainstorming process that we love that we've seen good advances come from.
Sketching is, to your point, visualizing is so important, and it transcends languages. So, we work very closely with our Japanese counterparts. We don't always speak the best Japanese, they don't always speak the best English, but when you visualize it, you understand it, right?
Yes.
So yeah, that's absolutely critical.
So I understand that Toyota's been working on fuel cell technology for about 30 years. Can you touch on, let's say, a major advancement in fuel cell technology in, let's say, the last 5 years?
Ooh, in the last 5 years.
Like a breakthrough moment?
I think the breakthrough moment that we had was when we launched the first generation Mirai, which was 2015. So coming up on 10 years ago. And that was, we developed a new component that could match the voltage of the fuel cell system to the voltage of the hybrid synergy drive system, which, as you know, we build a lot of hybrids.
Yes.
So we were able to use all this off-the-shelf hybrid components and just mate them with the fuel cell system. Since then, we've just continued to, increase the density, the energy density, the power density of the fuel cell. We've been able to reduce cost, but it's been kind of a steady, innovation of the fuel cell stack itself. I think what's happened in the last 5 years is looking at new applications where we can use the fuel cell technology that we previously had never even considered, right? Again, we're a light duty vehicle manufacturer. We build Corollas, we build light duty vehicles.
Right.
And now all of a sudden we're putting fuel cells into Class 8 trucks. We're putting them in cargo handling equipment. We're building stationary generators, right? So the innovation hasn't been in the fuel cell technology per se. That already is production ready, right?
Okay.
We already sell the vehicle. We're already producing the fuel cell.
Right.
The technology's already there. It's in the new applications that we're branching out into. And as Toyota now becoming essentially a tier 1 supplier, which we aren't, we're an OEM, major automaker, right? We're not a supplier. Now all of a sudden we're becoming a supplier of fuel cells to these other OEMs that are building, previously diesel-powered pieces of equipment that now want to use our technology.
If you don't mind, I'm going to grab a fuel cell.
Please do.
So you were kind enough to send these. Thank you very much.
Yes.
Could you talk to us a little bit about what we're looking at here?
Yes, indeed. So you are looking at the GDL, the gas diffusion layer, and then one of these is the cathode, the other one is the anode. So essentially all of these individual little channels here are meant to introduce the hydrogen on one side and the oxygen on the other as homogeneously, which means as uniformly as possible on each side. And so this way, again, when you introduce the two together, you get that electrochemical reaction happening all over the cell. So that's how we get the best power density, right? Because we don't want just there to be a concentration of hydrogen here and oxygen here, and so we're not getting that reaction across the entire cell. We want this entire cell to be very active.
Yes.
So what you're seeing here is all of these special, really finely manufactured channels to introduce the gas on either side. And then again, there's a membrane that sits in the middle that isn't here in this particular piece. But that membrane will prevent the electron from going through. It'll find the conductive circuit around this. If you're holding it like this, this is all conductive, so it'll find its way around, meet up with the oxygen on the cathode, and then turn into water and go out the exhaust.
So is this now considered, let's say, an OEM component that Toyota would sell to others that want to make a fuel cell?
So we do, this is manufactured in Japan. We do manufacture these. This is, we don't sell these individually because selling these individually wouldn't be sufficient. A supplier wouldn't know what to do with these.
Okay.
There is a lot of controls that goes around this. Again, since it is a chemical reaction, you need heat, you need humidity, and you need to maintain the proper stoic or the proper amount of hydrogen versus oxygen to maintain that chemical reaction occurring as efficiently as possible. The formula, the algorithm, all of the, you talk about programming, all of these pumps, all these compressors are all programmed by our engineers to make sure that we're using that hydrogen as efficiently as possible. So we could we sell this? Probably. Would it be useful? Absolutely not.
Right, because you need the whole system.
That's right. That's right. So this is one fuel cell, right? And it's actually, we have machines that stamp these together, but then you just lay on more fuel cells, and that's how you get as much power as you need. So this guy right here probably can put out 0.6 volts.
Okay.
If you want to build, for example, a Mirai, we have 330 of these guys in series.
In a stack.
Yep, and it's called a fuel cell stack, exactly. The beauty of that is that you can have one of these to power something pretty small, or you can have 330 to power a Mirai, or 660 to power a truck, and it's very scalable. The energy is not stored here, right? So this is all inert. This is, not non-toxic metals. We can recover a lot of the platinum that's used as the catalyst in there. So as far as toxic materials, fuel cells are very, very benign. And then you store the energy itself is stored in the hydrogen. So that makes it more usable for larger applications when we talk about things like heavy duty trucks where it's just hard to get that many batteries into a heavy duty truck.
Yes.
We can get that much energy and hydrogen and store it on board and For example, our trucks take 15 minutes to refill, go 300 miles, and can pull a full load of 80,000 pounds. So fuel cells are very scalable. You can make them as small as you want, as large as you want, depending on how much power you need.
Love it. It's a great conversation. Thanks for sharing that with us.
Of course, this is how we hope to power the future.
So if we were going to look at the future a little more, could you project a little out into tomorrow's world? What do you see happening with fuel cells out there?
Oh man. Again, because of the scalability, the opportunities are really endless for fuel cells. I see them having a big play in the transportation space, but also in generators. We're seeing a huge increase in the amount of generators required for things like data centers, right? Mm-hmm. Those typically have diesel backup generators. Yes. People are done with diesel backup generators. Yeah. People are done with burning fuel, with carbon emissions. So I see fuel cells moving into the generator space. I see them moving into heavy-duty transport, cargo handling, as well as light-duty, and it will continue to be a part of our portfolio for zero-emission vehicles that we are offering to our customers.
Well, everybody, you heard from Jackie today on fuel cell technology. Thank you so much for being with us today.
Thank you for having me.
That's another edition of Tomorrow's World Today. Bye, everybody.
Thanks for listening to this episode of the Tomorrow's World Today podcast. Join us next time as we continue to explore the worlds of inspiration, creation, innovation, and production. Discover more at tomorrowsworldtoday.com and connect with us on social media at TWT Explore. And find us wherever podcasts are available.